Hello, my friends. I want to review with you some writing simple Lewis structures. This is the very basic part to start with the nomenclature series. Now, nomenclature comes from the Latin word nomen, and that means name. And we're going to learn how to name compounds in this series. The first thing we need to do, though, is write simple Lewis structures. First of all, what is a Lewis structure? It's also known as a Lewis dot structure or electron dot structures. And they're diagrams that represent the valence electrons of atoms within an atom or molecule. And so you'll notice here some examples. Oxygen has 6 valence electrons, so you'll notice the 1, 2, 3, 4. Notice we put 1 in each side of the actual symbol, and then we do 5, 6. Then we number or basically put the other electrons in with a pair. Just like Hund's rule, we kind of like mama feeds all of her Huns around the symbol first until we have a second round so they can get a pair. Fluorine has 7 valence electrons, therefore we could start here and we'd write 1, 2, 3, 4, and then we'd put 5, 6, 7. It doesn't really matter what side you start at. It doesn't matter if you start at the top or the bottom, but it does matter that you put 1 electron dot in each position before you add a second. Nitrogen has 5 valence electrons, and it's as indicated here. Remember, to determine the number of valence electrons of an atom, we have to look at the representative elements on the periodic table. So remember, if you recall, the alkali metals, they have 1 valence electron, and then the alkali earth metals have 2. Again, these are the representative elements. They don't include the transition metals or the inner transition metals. Then we come over here to basically our P block. We have 3 valence electrons, 4, 5, 6, 7, and 8 valence electrons. The goal is to have 8 valence electrons so that you have a full, stable outer shell. So what I'd like for you to do is place the electrons around the chemical symbol, and I did put a little periodic table in here, but I would advise you guys to have your periodic tables out and handy. First one is phosphorus. So if I go look at the periodic table, I find phosphorus, and phosphorus is 1, 2, 3, 4, 5. It's in the 5th group here, showing it has 5 valence electrons. So I literally write the letter P or the symbol, and I add 1, 2, 3, 4, and now I can pair up as 5. My next example is barium. So I find barium on the periodic table. Barium has 2 valence electrons. So I write Ba, I write the symbol, and I simply place 2 valence electrons. Notice I did not put them next to each other as pairs. You have to spread them out first. Finally, neon, and neon, as you'll find, as a noble gas. So if we finish them up here, then, whoops, my bad. Neon has 8 valence electrons. So therefore, I come over here, I write Ne, 1, 2, 3, 4, 5, 6, 7, 8. I have a full Lewis structure. Now you try a few, and what I want you to do is as I go through these, I'll show you the problem, you pause your video, and then I'll show you the solution. Arsenic. Go find arsenic on the periodic table. Okay, to find arsenic on the periodic table, I come over here to AS, and I'm going to find here that AS is in group 5. If I count them across, 1, 2, 3, 4, 5. So I write AS, and I place 5 valence electrons around AS. The next one, radon. Go ahead and find radon. Okay, radon is actually a noble gas, and it's behind me on my photo here on the screen, but radon is a noble gas. So radon, therefore, will have 8 valence electrons. So you have 1, 2, 3, 4, 5, 6, 7, 8. Again, that's the Lewis structure for radon. And finally, the third one is cesium. Okay, you found cesium as an alkali metal here, and it's just in the first column. So I just put cesium, and I put 1 little electron next to it. You guys, all you have to do is remember your valence electrons based on your representative elements on the periodic table.